Hello guys, in this video I'm gonna show you how to solve next interval problem. So given an array of intervals, find the next interval of each interval. Right. In the list of intervals for an interval I is next interval j, we have small start greater than or equal to the end of I. Write a function to return an array containing indices of the next interval of each input interval. If there is no interval of a given interval, return -1. It is given that none of the intervals have the same start point. Okay, so there's a lot of information here. Let's take a look at an example here. So given this list of intervals, right? Okay, our goal is to return a list of indices, right, of the next interval of each interval from the given input. So if there are three intervals here, the output should be an array of three numbers, right? Each number represents the index of next interval, right? So for example, the first number here will be the next number here will be the next interval of this one. 2 will be the next interval of 3, 4, and -1 will be the next interval of 5, 6 here, right? So actually, 1 here, these numbers are index of the next interval, right? So for example, 1 is correspond to 2, 3, right? This interval. So it means the next interval of this interval is at index 1, so it should be 3, 4 here. Same here. The next interval of this interval is 2, index 2, which is this interval. So next interval, this one is this one's, and last next interval of 5, 6 is at index -1, which means there's no next interval of this interval. Okay, that is how we wanna return from these functions, right? So what is the next interval of a interval? Here, here the next interval of this interval, which has start time at 2 and end time at 3, will be an interval that has the start time greater than or equal to the end time of the current interval, which is 3. So the smallest start greater than or equal to end time of the current interval is actually this one with start time of 3, right? We both of these intervals has start time greater than end time of this interval, but we want to take the one with smallest start time, but still greater than the end time of the current interval, right? Um, so how can we solve this problem? Right. Mm, so kind of so for this interval, for each interval, right? We probably want to, like, if we select one interval, we probably want to access to kind of smallest, right? Smallest start time, but still greater than the current end time, the end time of the current interval. So it is probably has something to do with a mean heap, right? So um, one problem we need to solve here: select one interval. Uh, we need to find from remaining, right, intervals uh, smallest smallest start time is greater than or equal to end time of current interval, right? So this is probably something has something to do with a mean heap. Okay, mean heap based on the start time, right? Based on start time. Okay, great. So how about iterate through each interval, right? And mm, iterate through each interval, and we can somehow, let's call it, for example, here we have x, y, z, y, z. Okay, so for example, we select x, and we wanna find from the remaining intervals the interval that is has smallest start time still greater than the end time of the current interval, which is x. So after x, I will come to y. Um, we uh, do we really need to? So if uh, we do the same with the previous interval, I will select y and find from the remaining intervals. So it has some problem here, right? Which is like at each step we need to uh, find interval with start time greater than a certain number, right? But um, so in order to do so, I need to somehow keep uh, popping out from the mean heap, right? Until a point that the peak of the mean heap, the peak until the point the peak of the mean heap is uh, is greater than the end time of the current interval. So for the next interval, I will probably, if I do the same, um, I will again, I need to reverse the state of our mean heap, right? Which is something not very efficient, I think. So one thing we can do here is I wonder if we can use two heaps here in order to uh, limit the the number of operations we need to do here. So how about having one here we need a min heap based on start time. How about having a another min heap based on end time? So for example, uh, like from this given, so instead of iterating through the intervals, I will I will take one interval from the min heap based on end time in state. So at any given point in time, I always have access to the interval with smallest uh, end time, right? So in this case, it is 2 and 3, right? With smallest end time amongst 3, 4, and 6. So if I take this one, then okay, um, if I select this one, I will look at the other min heap that based on start time, right? So we will remove all the intervals that has their start time uh, less than the end time of the current interval, which is 2, 3 here. So by doing so, I will take advantage of the fact that all the intervals that is removed from that min heap will not would not be a next interval of uh, any interval that we consider. Uh, oh, let's try to run through it manually so you can see it clearer. We have to heap, right? Mean heap uh, based on end time, right? Mean heap based on end time. So we have 3, 4, 6. X, Y, Z. It's the same order actually, right? It is sorted. It is inserted accidentally here, right? It has no mean that it is sorted already, right? Just a random uh, interval list. Okay, so mean based on n time. So here the one with the smallest n time, right? 2, 3 here. We also have a mean heap based on start time. So XYZ, and also here smallest start time will be X, right? Which is 2, is the smallest among 2, 3, and 5. Okay. So we start to iterate. Take one now from this interval and this heap, right? Take one now. Try to find the next interval for the current interval. So take one now, which is x here, right? X. Okay, target x. We target the x here. So we remove x from the this heap, mean heap based on n time, and we're trying to find the next interval for x, right? So we need one interval that that has the start time greater than the end time of x, right? So any interval um, that has its start time less than end time of x will not be the next interval of x, and also will not be the next interval of any interval in the mean heap based on end time, right? Because any interval, any remaining intervals in the mean heap based on end time will have its end time greater than the end time of x. So that is why. Um, so by doing this, we can eliminate a lot of operations we need to make, right? Um, so target X. Okay, we start look at the smallest start time, which is X here. It has a start time of 2, which is not greater than the end time of target here, which is 3. So we need another number. We pop it out from this one, and the next one here that comes up here is y. So y has start time of 3, which is greater than or equal to our target end time. So we can conclude that this one is the next interval of x. So target x will have x will have the next interval is y. Okay, after this, I will remove y from the heap, right? So here the next, the pick, this mean heap, next pick, right? So, okay. So now we pop the next interval from this mean heap based on n time, which is y. Remove y from here. So we need to find the next interval of y. So what is the, gonna check the peak of the other mean heap, right? Check to see if the start time of the peak is greater than the end time of current interval. So here, start time of z is 5, is greater than end time of current interval y, just 4 here. So correct. So next interval of y is z. Okay, so we remove z from here. So next, okay, so again we pop out one interval from this mean heap based on n time z. What is the next interval of z? We look at the mean heap based on start time. There's nothing else in the heap, so so we can conclude that these has no next interval, so its value will be -1. Okay, that is how we're gonna solve this problem using two heaps, right? One heap is to get access to the smallest n time, right? Smallest, get access to interval with smallest n time, right? The other heap is to get smallest access to interval with smallest start time. Okay, let's cut it out. We need two heap here. Cons mean heap based on n time. New heap. Okay. It's an empty. We probably want to keep track of index here, the index of current interval, right? So we will add all the intervals into a heap, right? So as we popping it out from the heap, we must know what is the index of this interval from the original array of original input. So as we adding as we feeding new intervals to the heap, we probably want to attach index as well. So in order to do so, I will create a class of interval constructor with start time, end time, with index. This will take in from the argument and assign to um, instance attribute, right? And this dot index here. Okay, so here uh, we want to give an indications while initializing a heap, whether it is a min heap or max heap, right? So I use the third arguments as the indications. A, B here is the interval objects. So I can get access to min heap based on n times. So it will be what is that? A minus B? Not sure. So let's do a little bit check here. New heap. Let's say 3, 4, 1, 2. No. And A, B. I think A minus B will be no. A and B will be the max heap. So B minus A will be the min heap. Okay, but B and A here is the interval object, so because it min heap based on n times, so I will access to n time here. Okay, same here, min heap based on start time, new heap A and B, start time, start time. Okay, so we need to fit our two heaps with intervals. So I will iterate to the interval list, right? But here we need the index as well, so I'm going to use a traditional for loop. I is equal to 0, I less than intervals dot length, I plus plus. Okay, so let's current interval, right? Current intervals at index I. I'll destructure it now to start time and end time. So I will feed this heap with a new interval with start time and end time of the current interval, and also the index, which is I here. Same here, we need based on start time. Okay, so after this loop we have two heaps, right? With all the intervals on the input, right? Given input. So from here I start to extract from min heap based on n time one by one, trying to find the next interval for each interval, right? So as long as min heap based on n time is size is still greater than 0, I want to get inside. I want to find. Okay, I want to pop an interval first. Current interval is min heap based on n time. Pop. Okay, I want to. I'll go here. Find the next interval for current interval. Mm, what is the we need to return an array at the end, right? So let's say output. Okay, it will be an array with the size of the interval size, right? Right. Initially it will be I will fill it with -1. Okay. Hmm. Our goal is to find the next interval for this current interval. In order to do so, I will check the other min heap, which is min heap based on start time. So as long as min heap based on start time, it peak, right? Which is the uh, interval with smallest start time. As long as still less than its start time is still less than the end time of current interval dot end time. I want to pop it down, and I want to just eliminate. I want to pop it, and I want I don't care about that interval because it will not be the next interval of current interval and will not be the next interval of any other interval in min heap based on end time. So I want to pop it down min heap based on start time. I want to pop it down. Okay. So after exit this loop, it means uh, it means it means that the peak of start time of min based on start time is greater than here peak of this one, right? Is greater than equal to current interval at end time. So it will be this one will be the next interval of current interval, right? So it means I can do something like output. Output will be a lesser number, lesser indices of next interval, right? So uh, the index here will be what? What do you think it will be? It will be the index of current interval, right? Current interval dot index, and uh, the value will be the index of uh, the peak, right, of the next interval here. Index, right? But it can be the case that this hit this mini based on n time, like after this loop here, main hit based on start time can be empty, right? So we have to do check that. We don't want to accept the peak if it is empty. So if minute based on start time, the length, the side bit is still greater than 0, I want to do this. I want to accept the peak time and do these operations. But okay, so here also can be the case that mean hit based on start time now is empty here. So it can be the case, right? This can be the case, but if if we if it slope come here, it uh, if we don't have this here, do we need to assign, because here we fill out the here we fill out the output with -1, right? Initially all numbers are -1. So if it doesn't come here, doesn't come inside here, this value will still be -1, and it is something that we expect, right? If it doesn't come here, the next interval of this, it means we can't find the next interval for current interval, so the next index of next interval will be -1. But if it here, I can, if it there's nothing in the minute based on start time, we probably want to exit the loop, right? We want to break, and everything else we don't have to find the next interval for any other intervals in minute based on n time, because it will be automatically -1. So if minute based on start time dot length equal to 0, I want to break. Don't want to go here, but if it go here, okay. So at the end I return output. Oops. Two hit. Nice. Four. Oops. It fails. Uh, what's wrong here? Minute based on enter. I. What's wrong here? Uh, based on start time. B minus A. Based on enter. And then so feed these two heaps, right? Pop on out from minute based on enter. There's an interval. So if the minute based on start time is that's not the inside, I'm gonna break here. If there's still something I want to pop it out as long as the start time is still or the peak is still less than the end time of corridor here. I want to pop it out. Probably here. Here, like the next interval of the current interval is this one, and we probably want to also pop it out from the mini beyond start time. Right? Okay, run it again. Okay, it works. So that is it for this video. Finding the next interval, right? Uh, so thanks for watching. See you in the next video. It's been a long one.